This is Chapter 1, Session 2. 1.2 Electric Field. For Session 1.1, we know there are two different types of charges. They are positive charge and a negative charge. We define proton carries positive charge and the electron carries negative charge. For here, let's just pick one positive charge and place it here. These are called electric field lines, or simply field lines. Arrows are pointing, as you can see, these field lines are pointing outward from the positive charge. From the direction of the arrows, we know these field lines are leaving this positive charge. In conclusion, for positive charges, electric field go outward from the charges. This arrow is just a graphical way to show electric field. It's a graphical method that helps us to learn how charges interact with each other. However, in the real world, we cannot see them. However, we can apply a different method to see the field. How about now, let's put the other type of charge, the negative charge here. As a recap, the negative charge has a minus sign inside this sphere. As you can see, those electric fields are pointing towards this charge. It is defined this way. Okay, let's put the first positive charge and the fields over here. Now let's put another charge here. As you can see, the one on the right hand side has more arrows or more field lines, which means it has stronger field. The field has higher intensity. So the number of lines indicates how strong the electric field is. For a weak charge, it has less field lines. For a strong charge, it has more electric field lines, which means its intensity is high. Now let's get more space here by putting the second charge in the center. The third charge has more field lines. Obviously, the last one, the third charge, is the strongest charge among all, since it has more field lines. Okay, now let's look at one scenario. We put one positive charge here and another one there. Currently, there are two positive charges in the workspace. What happens if we place them closer to each other? Right, we place both charges towards each other. So when we place them here closer, as you can see, the fields are banded. If we continue putting them closer, their field lines bend even more. If we continue pushing them towards to each other, their field lines are crazily bended, way more than before. Imagine if we hold these charges by hands. One hand grab one charge, the other hand grab another one, and push them closer to each other. We can feel there's a strong force that these two charges repelling each other. So the conclusion is same charge, right? Same charge. In this case, both are positive charges repel each other. How about now? Let's try both negative charges. And then we try to place them closer again here. As you can see, the field lines are bended again. If we place them closer, the lines are bended more, way more than they are further apart. So our conclusion is same charge, repel each other. What happens if we have a positive charge and then we get a negative charge? We try to put them closer and closer to each other, right? If they are very far apart. Let's use an extreme case. For example, one charge is in Los Angeles and the other one is in New York City, that far. There's no interaction, or the interaction is very small, very weak. But let's place them together or closer to each other here. As you can see, once we place them closer, the field lines coming out from the positive charge enters into the negative charge. Or we can say the field lines of both charges are connected. They are holding hands. So our conclusion is different charges, they attract each other. Imagine if you use our hands, right? Again, one hand grab one charge and we try to separate both charges. We can feel the attraction force between the charges. In order to separate them by hands, we need to apply more force. This force is called electric force. So this is section 1.2.